Hello again! In the last video, we created the power values on the battery and the character. And in this video, we're going to set about the character getting powered up. That is, gaining power from the pickups that the character picks up. So let's go ahead and get started. One thing I forgot in the last video that I want to take care of real quick before we do that though, is we never set default values for our initial and current power in the character class. So I'm going to scroll back up to the constructor, and down at the bottom, let's go ahead and add those. So we're going to set base values for the characters, for character power. And again, these are just base values. These can be edited later by designers, but we just want something so we don't start with 0. Initial power, and let's just go ahead and say we're adding 200. We'll go ahead and set the initial value to 2000. And then, of course, current power equals initial power. Okay, that's all we needed to do. I just forgot about that in the last video, so I wanted to get that out of the way. All right, now let's scroll down to where we're going to handle this adding power. And we're going to do that when we collect the pickups. That's how we're going to handle it. So the way we're going to do this is we're going to go through our pickups, and if we have a battery, because remember we could have different types of pickups, so if we have a battery, we're going to add up the power from that battery to a summed up total power for this test, for this round of collecting. And then we'll one time update power using that final summed up value. Okay, that's how we're going to do this. So let's go ahead and get started here. We're going to create a variable to track our total power and initialize that to 0. So this will track the total power collected, or the total power found in batteries. Okay, and so what we're going to do is we're down here. We've got a pickup actor, or an actor. We cast it to a pickup. It is a pickup. So, and we know that it's active in here. So here we're going to go ahead and first we need to make sure if we actually have a battery. And this logic is following along with Epic's version of this tutorial, so it's going to look pretty familiar. So we want to add power if we found a battery. So we need to do the casting, and in this case I'm going to use that little trick. I'm going to do it inside the if check. A battery pickup test battery equals, and we cast it to the class a battery pickup. Whoops. And we're passing in the test pickup. Okay, so if that's true, now we have a valid test battery. So we're going to take total power and update it with the test battery's power using that get power function we defined last time. We have the squiggly lines because we did not, I don't think, nope, we didn't add the header. So we have to include the battery header, battery pickup. Okay, now when IntelliSense catches up, that will take care of that problem. And now let's go back down to our function. And now what we've got is basically we're collecting it and we're summing it up. And once we're finished, once we've finished going through all of those actors and we've totaled up the power, then here we need to actually add the power to the character using that update power function we defined last time. So we're going to change the character's power based on what we picked up. Okay, now we say if total power is greater than 0, then update power, total power. Okay, now are we done? Hold on a second. This is going to be a problem. What we've got here is an insidious little bug. Now, if you recall, we could have power that is both positive is either positive or negative. But if we use this check, what happens? Suppose we pick up a bad battery, and the bad battery gives us negative 200 power. Total power is now negative 200. Then we get down here, total power, negative 200 greater than 0, fail. We will not update the character's power. So this way of doing it will not allow us to do what we want. So there's a few ways we can solve this. One of them is to say, okay, well, it can either be greater than 0 or it can be less than 0, right? So let's just add that. Or total power could be less than 0. Well, that could work, but now we have a problem with the computer because we run into an issue with floating point arithmetic. Because the value of 0 and actually attaining that value with precision is actually quite challenging for the computer, and in fact is not usually handled very well. So saying this, if it's greater than 0 or it's less than 0, is similar to saying if it is not equal to 0. But this kind of check is very bad to try and do with floating point, because an exact match between two floating point variables is highly unlikely given just doing some arithmetic with those variables on the computer. This isn't because your code is bad, because on paper this makes sense. But the reality is in a computer it's not going to work. So we need something that's a little more robust. And the way we do that with floating point is we say, okay, what is our kind of scale? And given our kind of scale of numbers, we then use a kind of tolerance. So we say, well, if it's greater than 0, 0 is pretty precise, but maybe we want to give it a little flexibility and say, well, maybe what if it doesn't equal 0.001? So, if it was greater than 0.001, then any random fluctuation of floating point issues on the computer that generate a value between any negative number between 0 and 0.001 would still be considered 0. We still call it 0. Now, the way you do this is we could say, well, make sure it's greater than 0.001, or total power, if it's negative, is less than negative 0.001. And this is actually a pretty good way to do this because it will let us have what's called a tolerance in our checks. So pretty much any value that's around 0, we'll still call it 0. 0.001 is great for us because our values are in the hundreds or thousands. But this could be something that's not good enough in other contexts. One other thing, though, is we can change this and use built-in functionality that the engine already provides. And that is an fmath function called isNearly0. So now we have arrived at where I was actually headed with this. We can actually check if a value is nearly 0 using this function, and we pass in our value, the floating point value we want to test, which is total power, and our error tolerance, which can be left default, which is very precise, or we can give some much lower level of precision if we want, something like that. So there's a couple different ways to use the function, but in any case, we want to make sure that this value is not nearly 0. And so long as that is true, we will call it a value that's worth using to update power. Now, if you wanted to actually dig into this functionality to see what it does, simply hover over it and hit F12 by default, or you can right-click and go to the implementation, and you'll see that what they do is they take the absolute value and check for it to be less than the error tolerance, which we could have done as well, but it's a good practice to use functionality that the engine already provides you. So that's what we're doing. All right, that aside, we can now look back over our functionality. We're totaling up all of our power that we get from all the batteries, and then we're updating the character, which means we should be good to go. If we go ahead and flip back over to the editor and we compile, now once that's done, we will test this in an interesting kind of way. What we're going to do is go into the game, but I'm going to move the character over a little bit here, And then we're going to go into our world outliner and search for characters. Click on one of those, and we need to search for power, because our power category, and here you see initial and current power. So now let's go back over to the game, and I'm going to run out here somewhere and see if we can collect. Oh, look, there's one way out here. Hit E, and it will take a couple of seconds to collect, and you'll notice that now over here in the current power value on the right, it's now up to 2200. So I can go back over here and hit E, collect some more power, and that's 2400 because each of our batteries has 200 power level. And now we can go stand in the middle and just hit E and collect a whole bunch of these and get 6200 power out of the deal, which is pretty sweet. We're getting seriously powered up. 7400 power. I can just keep going. I can do this all day long. Just keep getting more power. Look, my power level's high. Okay, so we know that works. And that's everything we needed to do in this video. We're now able to collect the pickups. We're able to get power from the pickups. And so in the next video, we are going to set up the rules in the game mode to drain power out of the characters over time so that we have a game to play. And I'll see you in that